I'm Ismail Emir, and today I will represent my research about AlphaFold, in a state-of-art artificial intelligence system for 3D protein structure prediction. I will explain how AlphaFold works and where we use it. Let's start with proteins. Proteins are essential molecules for life. They perform such functions as catalysis, signaling, transport, and regulation. They all are so necessary for life. And the function of the protein depends on its 3D structure, determined by amino acid sequence, physical and biological forces. And predicting this 3D structure is a very difficult problem because there is many possible conformations that protein can adopt, and finding the most stable one is a very difficult. And there is such experimental methods such as X-ray crystallography and nuclear magnetic resonance, but these methods are time consuming, they cost very much, so they require years and years for thousands of proteins to be predicted. They are inefficient, and you need a computational method that can predict protein structure from sequences and not experimentally. So DeepMind, the artificial intelligence company, decided to develop an artificial intelligence system, AlphaFold, and they participated in critical assessment of protein structure predictions (ASP) in 2024, competing in the protein 3D structure predicting, and they achieved very unprecedented accuracy and outperformed all other methods by a large margin. They changed the game. AlphaFold can predict protein structures with atomic accuracy, even in the case there were no similar structures known, and it do it with minutes and hours, not years. So let's look at how AlphaFold works. AlphaFold consists of several modules that work together. The core module is of course the neural network, which is the hard part of AlphaFold. This neural network trained on vast sources of protein structures that predicted in past. That there's a dataset, protein bank, which consists 170,000 protein structure that predicted in the past. So they used this data set to train a neural network, and they also several modules for that predicted torsion angles and distance to 3D coordinates, and then a refined model to improve 3D coordinates. And also there is a module for estimating the quality of structure, because not all structures are perfect. They are not all perfect predicted. So there's several applications. There's many applications of AlphaFold. A Forbes article actually mentioned AlphaFold as the greatest achievement in AI. So let's begin with designing novel proteins. AlphaFold helps evaluating new proteins, designing new proteins. We need new proteins, design new novel proteins for catalysis, binding, sensing, sensor families, such as a protein, an enzyme for cleaning seeds, for example. We need them, and AlphaFold generate sequences for given structure, evaluate the similarity. It helps it. AlphaFold can be used for understanding the effects of mutations, such as COVID-19 in recent years. We can use AlphaFold to predicting the mutated protein structures, and we can prepare for mutations. And there is also very important use case, the potential drug invention of drugs. We can invent drugs with estimating their targets and inhibitors. We can cure diseases with inventing new drugs. And AlphaFold can help to identify potential drug targets and inhibitors and predicting their structures, so we can invent them. So, in conclusion, AlphaFold is a breakthrough in protein structure prediction. It has potential to accelerate scientific research and innovation in various fields of biology and biotechnology. By using AlphaFold, engineers can gain insights into structure and function of proteins and design new molecules. We can use these molecules, proteins, for nearly very much everything. Yeah, that's all. Thank you for listening.